Today is going to be more or less the same as what you've already been doing this week. I think, actually, I'm not quite sure what's so different from today's challenges from yesterday's. I don't remember, but we are going to be diving a little more in depth into ways to search through databases. So we'll be talking about how you could utilize regex as well as like statements and the differences between both, the pros and cons of each. Um, to start, let's do a bit of a recap. I think last Saturday you guys were learning about designing a schema step by step with Chad. So if you remember, you're essentially just identifying the entities that you need, and then you're identifying the relationship between these entities, and then you're diagramming a visual representation, and then you're writing some SQL. Fairly straightforward process. So today's example, we'll be working with grocery stores with a grocery store schema. And for this example, we're going to have a customer with a customer name and an email. We're going to want discounts for each of these customers. So, different membership types, discount rates, customer profiles. So like their type of membership. Maybe the membership is tiered, right? Like we have silver, gold, and I don't know, platinum level memberships. We will have items for the customers to interact with, and then they will have customer orders so that they could track the purchases that they've made. So I think you've already started to talk about relationships and the various types of relationships because there is a difference in SQL between things like a one-to-one relationship between tables or a one-to-many or a many-to-many. These are the various ways that data can interact with one another. And when you're designing a schema for whatever your use case is, you want to be mindful ahead of time of the kind of relationships you're going to be creating between your tables. In our case, we want customers to have a single customer profile. We don't want them to make multiple profiles. Let's say the profile should have 0 or 1 references to a membership type. Um, I mean, it doesn't make any sense to be part of multiple tiers in a membership. You're either at silver or you upgrade to gold. You're not in both. Discounts can belong to many customer profiles. That way, when you're creating, let's say, a website-wide discount, it can be made available to all customer profiles and not just a select few. Items can belong to many customer orders. That makes a lot of sense because why would you limit that otherwise? And customers can have many customer orders. Again, you don't want customers to just shop at your store once and then disappear forever. So thinking about these things, we can revise some of the entities that we have. So customers, well, this looks largely the same. What is different? Does anybody see a difference between this and what we had a few slides ago? It's just the order items, I believe, but let's backtrack and double check on that. Yep, it is the order items. We have added order items. I think the logic for this was customers can have many order items within their many customer orders, and items can belong to many order items. In the previous revision, without the what is it called? Without the order items, a customer order No, I'm not quite sure why I wrote that slide this way. Well, I think once we get through the exercises, this should come up again. I'm thinking right now that we want order items because we want customers to be able to have, oh, right. I think that way they're able to order multiple of the same item in an order. If you want like 10 cans of something as opposed to just the one can. So that was the revision that we made for this schema. I don't, yep, it looks like we do have a schema that was created using quick database diagrams. You guys have started using this, right? Cool. So in our example, we have everything starting with the customer. A customer can have a customer profile, which is linked to their table using customer ID. So if we were, for example, well, we'll go to that later. I was going to pull up the actual database, but I don't want to switch screens yet. Um, when we do get to the SQL, I'll show you how when you're writing a query to pull from the customer and customer profile tables, you could use a join and you'd be joining them through the customer ID. For a customer profile, we want to pull the discount based on their membership type ID because the different tiers will have different discounts available to them. The higher your tier, the better the discount. Now down on this bottom half, we have customer orders. And this is, again, utilizing the customer ID. And each order can have multiple order items, which is pulling from the items table as a source of truth. So table creation. I believe all of this is inside the Git repository in the init.sql, which is run by the shell script, the starting shell script. When you start exploring and navigating this database, we'll be using joins to pull data from multiple locations. This should already look somewhat familiar. If I believe you have already started playing around with joins, you know that there are different kinds. Our inner join will return rows that have matches in both tables. Left and right will search for matches from either the left or right. And then we have matching from either the left or right table with the full outer. And a better way to think about this actually is through a visualization. So let's take a look at this, for example. This is an example of an inner join. When you write your select to pull from one table with an inner join to another table, you have a direct connection between the common keys. If we wanted all the data in table A, including the data that is inside of table B, we do a simple left join. But if we want to exclude the data inside of B, then we can add a where clause specifying that the key in B is null. Similarly, we could do the same for right joins, and it's essentially the same thing for the outer join, but it's just a little more verbose. We have to specify that the key is null in both actually either A or B. So searching your databases, there are two ways to do this. You could search through regular expressions, and you could also search through using like statements. With regex, you have these following operators. A tilde allows you to search with case-sensitive inclusion. So basically, if it's important that your search returns the exact same case type, then you will want to use the regular tilde. If case sensitivity is not so important, then you will use the star, the asterisk, to modify your search. So in row B, the second row, we have an example where with this tilde star operator, we no longer care about casing. Similarly, we could negate the search using the bang operator, which should not be too unfamiliar to you guys. Let's see, case sensitive search in this example returns 2 rows, whereas the insensitive search returns 4. Our search was select all from customer C, where the name has the letters I and S. In the case sensitive example, we have I and S in Wandis and Liesel, but in the case insensitive example, we include Isabella and Izzy. So again, the bang operator will allow us to negate from a search. So in this instance, we are searching for email addresses that do not use the .com domain. Regular expression matching matches for expressions. And you're already familiar with regex, so you should remember that you could use things like the regex 101 website to guide you in writing your regex expressions. It's even got this really cool, nifty quick reference sheet down here that can act as a reference to your use case if you can't immediately recall what the character notation is for that. What you'll commonly be using is the up caret to denote the start of a string. So in our example, select star from customer C, where C.email, up caret John. We basically want John to be at the beginning of our string. We could use the $sign to denote that the search should be at the end of the string. So here we're using that. Yeah, I see. I should have changed this example to use the $sign, but I guess I didn't catch that before. Let's see, what else? Regular expression character range for matching numeric types. If you want to search for all numeric types or just numbers between 0 and 9, then you use square brackets to denote a range. And you could also search for white spaces using a backslash and an S. Here we do have an example of our $sign. So we have it at the very end of our search. And this lets us know that what we're searching for is net at the end of a string. When we're searching for net loan without the dollar operator, we return other results like net vibes and live internet.ru. So utilizing these different operators will help you narrow down your search to precisely the right data sets that you need. In this case, we are searching for results that start with BE, case insensitive, and we could specify a capital BE to return the same results. A case insensitive search without the up caret will also include Isabella. And a case sensitive search with a lowercase only includes Isabella. And here we have an example of us searching a range of numeric characters, and it's returning all of the emails that have a number somewhere in the email. And here we have the results that are returning white space. It's pretty straightforward, right, guys? Any questions so far? Like can be used instead of regex, and it is a little simpler and a little easier on the eyes. So just like with the regex, you have various ways to specify case sensitivity versus insensitivity and to negate. Um, when you're using like operators, you could use I like to stand for case insensitive inclusions, and you could use not to negate your search. We can also use wildcards with a like operator. Um, you guys are familiar with wildcards already, right?
Yes.
Cool. So like when you're using a wildcard, like a star wildcard in the start of a search, you could use the percent symbol wildcard when you're using your like operator. So in this first example, we want results with the word the appearing anywhere in the middle of the results. And if we want to find only a single letter A, we would specify that we only want a single letter with the underscore. And let's take a look at what that looks like. In our first example, we are saying select all from customer where the email is like a wildcard. So basically anything that starts with A. And here in the bottom, we have anything that ends with edu. So the percent symbol represents 0 or more characters in a pattern. And it could be used to start and or start and end a search pattern. If you want to search specifically for a number, a very specific number of characters, you could utilize the underscore and you could utilize it multiple times. So here in our first results, we have emails with only one letter A. And in the second, we have this first one's throwing me off. I only see one A in this first result. I thought these would be, it looks like, oh, sorry, I'm thinking about it wrong. Okay, it's placement. So we want, in this first example, we want emails where A is the second letter. Basically, the underscore will denote any character. So the search is any letter and then A and then a wildcard to denote anything can follow afterwards. In this second example, we want A to be the third letter. And so we use two underscores to denote any character followed by the A in the third position. So which do you use between regex and like? It really boils down to preference, I would say, a little more than use case, because what you could do with one, you should be able to do with the other. And so it's really preference to which you're more comfortable with, which has the easier syntax to remember. But I would recommend familiarizing yourself with both. Mm. Generally, like is the easier one to use. So if you have a simple search, use like. That's at least how I think about it. And if I have a more complex search, I'll use regex. So like is really just actually a text equivalent to the tilde operator. We use a tilde operator to search through regular expressions. but you could just as well type double tilde to in place of like, and it will give you the exact same results. So in this example, we have the same results for the last two searches. The search select all from customer with the email tilde a wildcard, it returns nothing. But with like, it's a little more forgiving. It returns all four of these because the syntax is correct, whereas regex did not like this wildcard symbol. But here, we're able to use the double tilde and the wildcard together, and that essentially is the exact same thing as writing like. So yes, pros and cons. Regex could be a little harder to read, parse, and apply. It could be also a little more resource intensive and slower to return your results, but it does give you more flexibility and specificity. Oh, right. I didn't cover this in my slides, but it does also allow you the use of advanced functions like replacing using substrings, splits, etc., which you can't really do with the like operator. So one optimization for the like operator, however, is the optimization to short circuit. So this is less resource intensive. It is quicker to fail if it doesn't return, if it's not going to return the results you don't need because the query itself is bad. Cool. So let's switch over to today's lesson, grocery store schema. Let's actually also pull this down. This is the README for today. I think all of this is pretty much the same as what's in the slides. Ooh, except some of these exercises which we could run through inside of VS Code. So let me pull up VS Code. And I am already inside of my database. If we were to type details for this database, we see we have customers, customer profiles, customer orders, basically everything that you saw inside of the database diagram. Let's start with simple query. We're going to select everything from customer. Whoops. I need my from. So this returns all of our customers. Whoops. There we go. And if we wanted to see our customers in relation to the customer profiles, let's do a select all from customer, join customer. Well, we also have to give customer an alias. So C, join customer profile, which I think is all one word, where c.id equals cp.id. Let's see if that works. All right, what is wrong with my query?
It looks like it's not ID, it's customer underscore ID for customer profile.
Like this?
Yeah, I think. Oh, wait.
Let's see.
I think you might also need to say on instead of where when you're joining.
Yes, good catch. There we go. We are able to see our customers that exist in both the customer and customer profile tables. And we're also able to see their membership type ID if they have it. Let's try working with a more complicated query though. So let's see who is inside of this database. We have, yeah, let's pick on Dalton. We are going to search, we want to find out Dalton's membership type. So in order to do that, we have to search through a few different tables. So let's select membership type and we'll do this from customer C and we will join customer profile. Call it CP. We use on instead of where because that's the right thing to do. And we will type where the customer ID equals the ID. And then we will join the discount table because we want, I guess that's where the membership types live. And we will do this where the membership type ID from the customer profile table matches the ID in the discount table. And where the customer name is Dalton. Whoops. Yes, I probably did mean to use cp on c.id equals, oh, I have two C's here. That's one mistake. He is a silver member. All right. What is the distribution of membership types among customers? Wow, that sounds a lot more interesting. So in order to search for the distribution of membership types among customers, we basically want to count the number of memberships there is of each type. So we could do this by doing a select count, and we want to pass in the star to denote that we'll be searching all. And we will also want to see the membership type. We're going to pull from the customer database, which we're going to call C. And then we want to join this with the customer profile table, which we give an alias of CP. And we will do this on the customer ID matching the customer profile ID. Now we want to use a join to join a discount table. And we are going to pass in our membership type ID to have that equal the discount ID. And then we're going to group by membership type. And I have another error. Let's see. When we're joining the customer profile, syntax error at or near customer profile. I don't need this comma. So we have 8 silver members, 9 gold members, 10 bronze, and 23 who are not part of this special membership type program. Cool. So there are a few more queries in the exercise. Instead of just sitting here and doing them all in front of you, I'm going to have you spin up the grocery store DB. Once you have this set up and you're inside Postgres, start running some of these more advanced queries just to play around with the joins, with selects, with group bys, and then you'll be using the exact same database for the challenge. Any questions? Cool. I will open up breakout rooms, but first take a 15-minute break and we will reconvene at 9 o'clock to go over the Blue Apron schema design challenge.